Hi everyone. In this short video, I will go through an example of programming PLCs using CFC or continuous function chart programming. I already have created the project. Let me just switch the screens. So here I have the visualization for the project, and I'm already in the running mode right now. I just play or run the program. So as you can see here, I have a couple of switches. I have two sliders, and I will explain you why do I have them. First of all, here I have an on-off switch, which is used to turn on or off the whole project. I have a switch here, which is used to turn on the pump at the inlet. So if I turn it on, you will see the liquid starting to fill the tank. And if I stop it, so that the pump will stop and the level of the liquid will remain the same. And I have a slider here as well, so by that I can change the flow rate for the liquid flowing inside the tank. On the other side, I have another switch which is used to pump the liquid outside of the tank, for which again I have a slider to change the flow rate. So I can set it to the maximum value, or I can set it to some minimum value here, or I can turn it completely off. Okay, so that this is indeed what I have in the visualization. So we can change the flow rate for the inlet or flow rate for the outlet, and we can turn on or off the input and output pumps, and we can turn off everything with the switch that I have here. But the level of the liquid will remain same when we turn off everything. Okay. So for this visualization, I have used several items. I will explain them one by one to you. And also I have in background a program which is developed using CFC, for which I have declared a couple of variables, as you may see here, of different types. Boolean ones. I have an up-down counter here. I have a blink variable, which is a function, a standard function. I have also a limit alarm function, as explained in one of the indeed in the last video that I had, and I have a couple of other variables. And now I will explain you how the CFC program works and why do I have different items over there. So before going into that, let me explain you the functionality of the simulated tank here. So let's assume that now the input pump is turned off, as we have it here. If I okay, I need to turn it off. Okay, now the input pump is turned off and the output pump is turned on. You can see that the level in the tank goes down. However, when it goes below a given threshold, the output pump will turn off because there's no water or there's no liquid to take it from there, and we will have a given minimum level for the tank. At the same time, if I just turn off the output pump and turn on the input pump, you can see that the level in the tank starts to increase. However, whenever it reaches some threshold value, which is the highest level that we have in our mind, the input pump will turn off. And if I start to pump the liquid outside, you can see that at some point again the input pump will turn on, and depending on the flow rate that we can set from here, the level in the liquid will start to increase. Okay, so we have two kind of control here. We can turn the pumps on or off, and we can change the level of the flow rate of the pumps. So now let's see how this is implemented using CFC programming. Here we have a couple of elements. First of all, I'm using a up-down counter here to simulate the level of the liquid in the tank. So as you already know, it receives two inputs for counting up or down, different inputs. For the first input, which is used for the counting up, I'm providing the input using an AND gate or AND function as you wish, which receives a blink, the output from a blink function block, and it receives another input, which is the output of another AND, and it comes from a pump input, which is a Boolean variable, which is indeed the state of the switch here. You can see that as I change the state of the switch, the value of the pump input should change from true to false and the other way. And at the same time, this AND receives the output from the limit alarm function block. It receives the output of the limit alarm function, which is the O or overflow indeed overflow output of the limit alarm function block. And for this function block, for the limit alarm, we have like 3 inputs, as you should know, referring to the one of the previous videos. So we have the input which comes from the output of the counter, which is indeed the level of the liquid in the tank. Then we have some tank high level and tank low level, which are the thresholds. As you should know, the O output of the limit alarm will turn on. It will become true whenever the input goes above the high value. And the U will turn on whenever the input goes below the low value. And IL output will become true while the input value is between high and low. And I have also negated the output of the limit alarm here because I needed it in that way. I will show you how to negate it later. And you can see that the output is connected to the input of the AND, and then this output of the AND is fed into the input of another AND. And here you can see the output of the first blink function, which provides us a signal which is a square wave in it with a given frequency that I will talk about it later. And as a result, here we will have the output of the AND being fed to the input of the upcounting part of the counter. So let me maybe I will show you when we have the output of the AND as the square waveform. Okay. Now if I turn on the switch here, you can see that here we have true, and the output of the blink becomes true and false. So here, as the input of the CU input of the counter, we will have square waveform, and as a result, the output of the counter will start to increase. And that's what you can see here, maybe. Okay, so let's see how this slider here works. Let's just turn the input pump off, turn the output pump on to empty the tank. So as I already explained, this slider determines the flow rate for the input. Yeah, if I increase it, you can see that the tank is filled quickly, and if I decrease it, the tank will be filled slowly. And I can explain it here maybe. So when I change the value of the slider here, you should notice that the in rate here changes. So right now I have 36, and if I change it to 70, I have 76 here as the in rate variable. Then here, using the integer to time, I'm converting this value into some time value, and then I'm subtracting this value from a fixed value that I have here, 100 milliseconds, and then I will have some value here which is used as the time low and time high inputs of the blink. So indeed, I determine the frequency of the square waveform for the blink here. And the blink is enabled using the start push button that we have. As a result, what we have here will be the square waveform for which the frequency is determined by the slider here. And since the output of this blink is fed into the input of the counter, the higher the frequency is, the value of the counter will increase faster. And if we have the frequency of the blink's output is smaller, the counter will increase slowly. And we have similar setup for the outlet pump indeed. So if we switch, let me switch the input valve off. Now you can see that if I increase the slider's value, the liquid gets empty quicker, and if I set a smaller value, the outlet flow indeed becomes smaller. And that's what we have here. So the out rate variable here receives the value from the slider. So right now we have 11, and if I change the location for this slider, we will have 70 here. Again, time integer is converted to time, and then it's subtracted from the 100 milliseconds. The result is fed into the time low and time high input of the second blink, and as a result, the output here will be turned on and off, or we will have a square waveform with the determined frequency. And then the output of the end here, which receives the input from the blink, and it receives the input, the second input from here, which I will explain right now, is fed into the countdown input of the up-down counter. As a result, whenever we have the square waveform here, we will have the value of the counter decreasing. The other output input of the AND here is provided as the output of the another AND here, which receives the input as pump out. So that pump out is indeed determined by this switch. As I turn it on or off, you can see that the variable here changes from true to false, and so on and so forth. And the next input of this AND comes from the U output of the limit alarm, and I have made it negated because that's the way in which it should work. Yeah. So it means that as far as the limit alarm has the U output false, or it means that as far as the level of the liquid here is not below the low limit, which is this value here, then here we will have true value. And as a result, we can turn on the outlet pump, and then as a result, the level of the liquid could be decreased. Otherwise, if the level of the liquid is already below the low limit, we cannot turn on the output pump because it doesn't make sense, yeah, to do so. All right, so I already explained the limit alarm, as I think, and I also explained how the blinks are working here. Okay, so in terms of determining the value of the value for the tank level, we need to convert the output of the counter, the current value of the counter, from word to real value, because we needed to have a real value for the tank level. And also for providing the input for the limit alarm, we needed to convert the output of the counter from word to integer value. So we may need this kind of conversions from different type of variables to some other type of variables sometimes. Okay, so I think that's all for the code. One more thing here is that the blink and limit alarm functions are the functions which are available within the util library. I can show it to you later, but you should already know how to introduce or how to add a new library to your project. One more thing here is that for the okay, let me explain you the visualization part by logging out, because I will have more freedom then to go into the properties of different items. So here for the tank, I'm using bar display. Let me see the properties. Okay, they are here. Okay, so properties of the bar display are here. I have determined the width and height of the bar. I have no scaling, so that's why you don't see any scale here. And I have determined the start and end, and also the main scale and subscale for this. Okay, so the value here, yeah. So the value for the bar display is coming from the tank level variable. And one more thing here is that now we have a vertical bar display, and you should know how to make it. Yeah, whenever the height is bigger than the width of the bar display, it becomes vertical. If it's not the case, then the bar display will be horizontal. For the sliders, the variable is related to the in rate, as we already have seen, and we have starting from 10 and ending at 100, and same thing for the other slider. This one is related to the out rate variable. One more thing here regarding the pipes somehow is that they are we have some variables. So the color variables here for toggling the color is coming from the pump input on, and that's something that we set inside the CFC code. And whenever we have the value of this variable changed, then we will have the color changing from white into this navy blue, and you can determine the color of the navy blue color in the properties. And the same thing for the other ones, but for this output pipe, the variable is pump out on variable. Okay, so I think that's all about the visualization part. And then regarding the code here, so there are something that I can show you. Whenever you have an output and you want to negate it, so similar to what I have done here, you just need to right click on it, click and then right click and select negate. If you do it 2 times, you will go back to the original case. One more thing here is that whenever you have a block and you want to increase the number of pins for that, after selecting it, right clicking, then selecting pins, you can add input pin. Then if you have some extra pins, you can right click on it, select pins, and then remove the unused pins. So that's something also which could be useful for you. And here now regarding the library, I already have added the library to the project. Okay, so I have added this library to the project, and the limit alarm function is available in this library, and also okay, I just need to wait. My computer takes some time. Yeah, and blink function is also available in this library. It's just to add a new library, you just click on the add library. And then it's here indeed. I have added it like this, but I don't need to do it because I already have done it. Okay, so I think that's all for this video. So this was an example of how to use the CFC programming to simulate something, and here we have simulated the tank, a liquid tank with some input pump and output pump, which for which we could have the control on the flow rate as well. So I have done it in this way, but there might be some other ways, maybe easier or more difficult ways to do it. However, as an example of how to use the CFC programming within the CODESYS, I think you can use this as one of the first steps. Okay, so that's all for this video. Thank you for watching, and don't hesitate to share the video if you think that it would be useful for someone else as well. If you need the code of the project or the archive of the project, please write a comment underneath the video on YouTube, and I will try to send it to you as soon as possible. Thank you for watching, and see you next time.